Okay, just to go over again the last time's work, because today we're gonna go into a new unit. Okay, so that's why we need to go over one more times how we find the solutions of the equations. Okay, the first one, I'm gonna try the first one. This one is the fractional equations. Actually, denominator doesn't have any x. Again, in this case, we set fractional equations. Actually, this is a fractional, right? Not rational. But we have variable in denominator. This was specially set rational equations, okay? A little different. But some teachers, right, they use, right, both. But the correct name of equation is what? Fractional equation. This one is the rational equations. These rational equations have variable in denominator. That's the difference, okay? So maybe you can use what? One fraction each side. You can use a cross product, or you can multiply the LCD. We have two different ways. First one is cross product or cross multiplication. And second one is you can multiply it by LCD. Okay. At this time, LCD, least common denominator, we have two denominators, 2 and 5, which is 10. I'm going to go this way. Times 10 over here, times 10 the other side too. So you can cancel out 5, okay? So 5 times 4x plus 5 is 20x and plus 25. The right hand side, this is 1, this is 2. 2 times x is what? 2x minus 1 times 2 is what? 2. Okay, no more fractions. Now you know how to solve this one. Constant, you can keep the variable in your left, constant in your right. Okay, so constant move to the right, negative 25, negative 25. So 20x equals to 2x minus 27. After that, variable terms move to the left. Okay, so how can you move to the left? Minus 2x minus 2x. That is equals to 18x on your left, right side, negative 27. After that, you can divide by 18s. Okay, x equals, you can divide by 9 and 9, okay? Alright, so negative 3 over 2. Okay, the solution is negative 3 over 2. That's the solution, okay? Remember, there are two different ways to find the solutions. First one is a cross multiplication. If we have one single fraction, one fraction, the other fraction. If a two fraction there, you cannot go cross multiplication. You have to go what? You multiply LCD. Is okay? Remember this one. Now the next one is we have left hand side 1 over 2 minus 2 over 4x, two terms there, right? So in this case, you can't use cross multiplications. You have to go with what? LCD. LCD is the least common denominator to 4x. 4x is going to be 4x is the least common denominator, right? We have a 3 denominator over here. 4x, 4x, anyway, 4 is a multiple of 2. Least common denominator will be 4 of x. You multiply 4 of x to each terms. 1 over 2 times 4 of x. I'm going to do 1 over times 4x is what? 2x. 9 over 4x times 4x is what? 9. 3 over 4x times 4x is what? 3. Replace with this one. So this one will be looks right this way. 2x minus 9 equals 3. This is simple. Okay. So isolations. Okay, you want to keep the variable in your left, and the constant move to the right. So plus 9 plus 9. So 2x equals 12. X equals 6. But you gotta be careful when you have solutions, because this is a rational equations. Because we have a variable denominator. After you find these numbers, denominator cannot be 0. You gotta make sure x equals 6 never be a 0, okay? Only if you got x equals 0, this one is not working. Okay? So this kind of solution which makes sure denominator 0, extraneous solution, okay? Extraneous solution means what? Fake solution. That is not true solutions. It's okay? Alright. When you have the more than one fractions, you have to use what? LCD, which is a common denominator. Okay? That's all. Now move to the next one. This is the same thing. You multiply to what? 2x squared, 4 over here, so LCD equals what? 4x squared, okay? You multiply 4x squared every terms. You can get the answer, okay? That's all. The next one, this is the same thing. What is over least common multiple? Because all this is denominator, there's no fractions, no numeric numbers, so this will look like this one. X minus 1, x plus 5. Second one is 18 over, you need a factor, okay? Always you want to find LCD, okay, denominator should be completely factored. So it's gonna be x plus 3, x plus 5. And that is equals to 9 over x plus 3. So we have 3 factors. X plus 5, x plus 3, another x plus 3. LCD is what? Only these two, right? They all have x plus 5, they are x plus 3. LCD equals what? X plus 3 and x plus 5. That's the LCD. Okay, multiply this LCD to every terms. The first term is what? We already got what? X plus 5 there, okay? So x plus 5 okay? This one over here, we multiply x plus 3, x plus 5. X plus 3 cancelled out. The first term will be, looks like this one. X plus 1 times x plus 3. Second one is we multiply all together over here, only 18 available. Last one is x plus 3 is out, still we got x plus 5. Now we need to solve it this way. So x plus 1, x plus 3. X times x is what? X squared. 1x, 3x is what? 4x and plus 3. Up to that's okay, right? And plus 18 equals 9x plus 45. We have many like terms. It should be simplified. This one is 21. So x squared plus 4x plus 21 equals to 9x plus 45. So we're going to keep the variable to your left. So this one move to the left. This is a quadratic. Alright? When you have a quadratic, one side should be 0 to prepare what? Factoring. Okay? When you have a linear isolations, quadratic, you need to set value equal 0. So, x squared, this one is a minus 9x. That is a negative 5x. Minus 45, minus 45. Okay, negative what? 24 equals to 0, right? We need to set 0. This is we set standard form. Always quadratic should be in standard form to find the what? Solutions. To solve quadratic or polynomial function, we have many different ways. First one, you can try factor. If factorable. If the equation is factorable. Second one is what is it? Quadratic formula. When you have a quadratic, degree 2 is a quadratic, okay? Quadratic formula. Or you can use complete this square. That's the different way, only what for quadratic. Remember this one, okay? But this was factorable. Two numbers is what? Negative 8 and 3, isn't it? So it's going to be factored this way. X minus 8, x plus 3 equals 0. So we have two values of x. X equals 8 and x equals negative 3. That's the solutions. But what about this one? We don't know. Find out because what? We have a variable denominator. we have a variable denominator, always check. If we have a number in denominator, you don't have to, but variable, always check. X equal 8 is okay. When x equal 8, that is not 0. This is okay, not 0. What about this? X minus 3 from here, minus 3 plus 3 is what? 0. Oh my god, this one is what? Fake solutions. This we said extraneous solutions. But this is not real. Out. Okay, always when you have a variable in denominator, which is what? Rational equations, after you find the solutions, you have to check. Okay, so extraneous solution will be eliminated. That's all. Okay, this is a rational equation. Now you guys know, right, how to solve when you have rational equations. It's okay. All right, that's all. This is the rational equations. That's fine. You can jump. But this is all okay. You can try by yourself. This is all the answer key over here. Okay. This is also rational equations. What is the LCD? LCD equals what is the x minus 5 and x plus 3. You multiply this LCD to the every terms. Okay. But after you find the value of x, you need to check. Denominator cannot be 0, right? Because this is the rational equations. Are you guys okay with that? This is the same thing, okay? And also, what is the LCD over here? When you cancel up, we can try this one because this is 3 minus x, okay? So this is what? X minus 3, x plus 3. Conjugate. Difference of squares can be factored this one. Okay? What about this? This is x plus 3, it's the same thing, but this is 3 minus x, this is x minus 3. It's the same factors, a little adjust this factor to the what? X minus 3, okay? How can you find it? This is x plus 3 minus change plus, because what? 3 minus x exactly equals to what? Negative x minus 3. Okay, we need a negative number, so we create this number with replace this negative x minus 3. We got the negative, another negative 3 is a positive. Okay, so 2 over x minus 3 now equals to what? 4 over x minus 3 and x plus 3. You're gonna adjust to get the same factor. Okay. Now LCD is what? This is LCD. You multiply this LCD to the terms. First of all, x plus 3 is out, you got the what? Only x minus 3. Second term is x minus 3 is out, you got the what? X plus 3. Okay, who is this? Okay. Alright, the next one, when you multiply LCD, this one only 4, right? Or this is cancelled out 4. You have to solve this one, okay? Just give me 1 minute. Okay, I'm sorry. So over here, x minus 3 plus 2 times x is 2x plus 6 equals to 4, right? So these two is like terms. X plus 2x is what? 3x and plus 3. This is another like terms. 3 equals to 4. Subtract negative 4. This is linear isolation, okay? Always. Linear is always isolations. So 3x equals 1. The value of x equals what? 1/3. 1/3 is no problem. They cannot never make denominator 0, right? That's the solution. Is okay? The idea from here, if you got 3 minus x, switch x minus 3, another minus. We still minus x minus 3, okay? Because when you switch over there, create a negative sign. After that, negative, positive. Okay? So it's gonna be x minus 3. When you switch this one, this sign will be positive. That's the rule. Okay? But this is rational equation, okay? Yeah, another practice. There are the answers there, okay? So after class you have some more practice. Okay? So better invest your time. This is we don't need this one today. This we don't need this one. We're gonna jump. This we don't need this one. Okay, maybe this is the identity. Okay, maybe if you have this a plus b squared equals to a squared plus 2ab plus b squared. If a minus b squared is what it is, a squared minus 2ab plus b squared. You have to memorize this one, okay? 3 over here. A plus b plus c squared is how much? First square, a little different. I'm going to square is the first. A squared plus b squared c squared plus 2 times inside is what? ab, bc, ca, okay? AB and BC and plus AC. What about this one? A minus B squared. Okay, this one it doesn't matter. Only positive. Okay, remember this one. Algebraic proof you can use. Okay, division. We did a long division already. X cubed minus 9 over x cubed plus 8. Only one times. X cubed, right? Eliminate. Subtract, that is 9. This is a quotient, we're gonna keep the right, divide the denominator. This is remainder, we still keep the denominator, okay? This is what it is. Quotient, qx plus rx, remainder over divisors, okay? Dx, this point. X cubed plus 9 is what it is. Times over here, okay? 1 times divisor times x cubed plus 8 equals to plus 1, right? That's the equations. But you gotta keep the right divisors in denominator, okay? This is the point. Alright, remember this one, okay? You know that x squared minus y squared is a difference square can be factored. It's conjugate form. X plus y, the other one is x minus y. But x squared plus y squared, this is known. It can be factored. But sum of cube is okay. Plus, it doesn't matter. This one can be factored. X plus y, same sign. The next one is what? First square. The next one is negative. This is positive. The next one is negative. Okay, negative. Not 2xy times xy. Okay, times xy minus second number square. That is the sum of this we said sum of cubes. You have to memorize this one. Difference of a cube. Alright, this is it. Difference of cube. Still working. X minus y, we follow the same sign. This is plus, this is plus. This is minus, this is minus. But the next will be positive. Same thing. Multiply these two, x, y, and the y square, okay? You have to memorize the sum of the cubes and difference of a cube, okay? But this is not necessary. This is review. You already know this one, okay? We don't need this one. A lot of work. Okay, we're gonna do this over here, synthetic division, right? So instead of using to give, right, we need we need the quotient and the remainder both. In this case, we use our long divisions. Second one is what? Synthetic divisions. Okay, but second one is only remainder. We're gonna find this. So we don't care about what qx, which is a quotient. Only our concern is to find the remainder. In this case, we can use the remainders here. What is the long division? You know that how to find the long division. Okay, from here I'm going to use synthetic divisions. Synthetic division is a quotient operation. Highest coefficient is what? 3. The next x squared is 11. X is what? Negative 6. Constant is negative 18. Make upside down division over here. To make a 0 over here, the value of x is negative 4 over here. Okay, that's the our starting positions. Okay, first number, okay, untouchable. Move down, just move down. Don't touch this one. The second one is multiply these two numbers and move up here. That is negative 12. But this time, that is upside down division must be additions, not subtraction. Okay? So you guys will use additions over here. Okay? Alright. That is negative 1. Okay? 11 plus negative 12 is negative 1. Negative 4 times negative 1 is a positive 4. When you add these two, negative 2. Negative 8 times negative 2 is what? Is a positive 8. When you add this one, negative 10. Yeah, this is not 0. This is remainder. But when you divide, okay, degree 3 by degree 1, the quotient should be degree x squared, degree 2, right? This is constant. So from here we can get the right quotient. Quotient is 3x squared minus x and minus 2. What's the remainder? Remainder is negative 10. That is okay? This one, if we want to find what? Only remainder theorem. What's the remainder of here? Remainder r equals what? If this is what? P of x, polynomial functions, what's the remainder? Put this number negative 4 into the here, that's the remainder. Remainder is just what? P of negative 4. This is the remainder theorem. Okay? Put this number negative 4 in there. 3 times negative 4 cube. Check it out. Remainder will be negative 10 cube plus 11 times negative 4 squares and minus 6 times, okay, negative 4 and plus minus 18. Check it out. 3 times negative 4 cube, negative 64, negative 192, right? You can use a calculator later, okay? This is 16 times 11. Negative 4 squared is a positive 16 times 11, 176 plus 24 and minus 18. This is negative 16. This is 8. I'm sorry, 6. That's going to be negative 10. It's the same number, right? So what is the remainder theorem? If we have this one, P of A, I'm going to use some number. P of negative 2 equals 10, 5. What that means? Remainder is 5. Just translate this way. When P of X is divided by x plus 2, right? Because the x value is negative 2 from here. Okay, that is the remainder theorem. This is the remainder theorem. Don't forget this one. Okay. And the next one. Very special case of the remainder theorem. What is that? Factor theorem. It's same thing, but a little different meaning there. Factor theorem is what? When you put up a negative 2, remainder is 0. When you have a remainder 0, x plus 2, I'm gonna use what the theorem. If P of negative 2 equals 0, then x plus 2 is a factor of px. That's the meaning. Because what? P of x can be expressed with x plus 2. This is divisor times some quotient. There must be some quotient, but remainder 0. Remainder 0 is nothing. So P of x is what? In product form, x plus 2, and the other what? Q of x. This is a factor, right? Because that is in product. Is okay? Why this is a factor? Put this number negative 2 there. That is 0, isn't it? Negative 2 minus 2 is what? 0. 0. This one has a factor, x plus 2. Okay? That's a factor theorem. You must memorize this one, okay? Okay, this is my opinion. Okay, that's fine. Okay, maybe I don't have to say this one, but I'm thinking something because the world has been changed a lot. To entering the college, good college, very comparables. I'm teaching one of the group. They are all Jewish students, around 8 students. Okay. I think exactly in your grade. Right, they work every time I gave a lot of homework, but they never missed it. They work so hard, very advanced. Okay, they are all attending in the Phillips Academy. They're very excellent private schools. Okay, very comparable. Okay, so I want you a little have some more practice. Okay, it's for you. Okay, not for me, not for anybody. It's for you. Okay, so after class, from today, after class, just review by yourself one more time. Okay, to figure out completely what we have done today. Okay. Anyway, we're going to the next one. Remainder. They're asking you only remainder when divided by x minus 9. Maybe you can write down this one. If this is a p of x, this is dividend. When you have x minus 1, this one looks like exactly this one, right? X minus times quotient. This is a linear factor 1, the remainder constant. That is the remainder of here. That's the relation, right? Because the left hand side, right side, if we simplify it and standard point is gonna be identical, same expressions. That's why we use some interesting property. How can you find the remainder of here? Just x equal 9. If you print x equal 9, they're gonna have the same numbers. Okay, both have the same result. Okay, so prove here. 9. Prove here the number 9 minus 0. This is R. That's the remainder. This is remainder theorem, isn't it? This number to make a 0, x equal 9, right? Put this number into the here, x, that's the remainder. So I'm gonna find the remainder. Okay, p over 9 is the remainder. 9 cubed, 9 squared, 33 times 9, and minus 37. This is the remainder, okay? Simplify. 9 cubed, how much? 729. Okay, this is 405. Okay? 297 and 37. Okay, I'm gonna use a calculator, okay? This time. I'm not gonna make a mistake. 729 minus 405 and minus 297 and minus 32. The remainder is what? Negative 5. Okay? If you want to express ax or rx dx form, you can use this one. X minus 5, x squared minus 33, x minus 37 over x minus 9. Okay? Quotient over here. And the remainder is negative 5 plus negative 5 over x minus 1. You can solve this one. But in this case, this is now our concerns. Okay? If you want to find this one, you have to use long divisions, and the other one is synthetic division, okay? Yeah, we did last time, it's okay. Alright, the next one, this is the same forms, but you can use long division, okay? But Okay, just one more over here. X cubed plus 12x squared. Because denominator is not linear, you don't have to use synthetic division. Synthetic division only what? Linear factor. This is a quadratic. If you really want to write the synthetic divisions, you have this with what? 2 times. This with the x minus 1, x minus 1, right? Use this one times and another one over here. But this case, better use the long division. X cubed 12x squared minus 42 over x squared minus 2x plus 1. The first is x, okay, times x. X times x squared is x cubed minus 2x squared and the plus x. Subtract, yeah, the both is out always. Okay, out. Negative 12 and negative 2x squared, they are like terms. Negative 12 minus the positive 2 is going to be negative 10x squared. There's no x in there. Over here, minus x, okay? But now this is constant, 42. We rearrange in standard form. After that, times what is that? Minus 10. It's okay? Minus 10. Minus 10 times x squared is minus 10x squared. And the plus 20x and the minus 10. You subtract over here. Negative x minus 20x is negative 21x. Negative 42 minus 10 is a plus 10, negative 32, right? But this is a square, degree 2, this degree 1, this is a remainder. Okay? But in the form over here, what is that? This one is actually, this form is exactly equals to what? This, we got the quotient. X minus 10 plus remainder is negative 21x minus 32 over x squared minus 2x plus 1, okay? This is this form. But in this case, quadratic, we don't have to use synthetic, okay? So you can try this one, okay? This is the x minus 2. From here, LCD equals how much? X times x minus 2, okay? Multiply all of this one to the every terms and rearrange, find the value of x. After that, you can check it out. The value of x is cannot be 0, x cannot be 2, right? If they have x is 2, that solution is extraneous. Okay, this is you multiply the common denominator, right? Over here, common denominator, 4x times x plus 1 is a common denominator. It's okay. Right, move this one. Factor completely, okay? We're gonna try this one, only this one. This is what 3D cube minus 4 cube. That is what is the difference of cubes. Difference of cubes can be factored. First number follow the same sign, minus 4. Second number, first number squared, 9d squared is 3d squared is 3d squared, right? 9d squared, not 3d squared. 9d squared plus, this is a minus, this is a plus. Multiply these two, 12d. After that, negative 4 squared is 16. This is a factor completely, that's square, right? You know that. Is it okay? Because 3x squared only one ways. We're going to 3x and x. Try and error. Or if not, we have to go by grouping factors. Is it okay? This is a minus 5 and plus 2, isn't it? We have already checked it out. That is negative 15x, this is 2x. Negative 13x, that's fine. If you don't find the y, quickly 2 and negative 5, we have to go by grouping. Sum is negative 13, product, we multiply this number, that's the product, okay? 3 times negative 10 is negative 30 is a product. What are two numbers? Sum is 13, negative 30, negative 15 and 2, isn't it? So negative 13x divided by this way, 15x and 2x. So replace with this one. 3x squared minus 15x and plus 2x and minus 1. That is vector grouping. We have to go this way. Okay? But try and error is only one case. This one is 3x squared can be factored 3nx. If we have a 6x squared, a lot of 6x, x, 2x, 3x. In this case, it better go this way. But if you are very strong, right, to use this try and error method, you can go this way. But this one takes time, right? But it doesn't matter. Grouping is what is there. 5x is common. So x minus 3, right? Three x is common, right? X minus 5. Okay, 2 is common, x minus 5. You gotta make sure we have right common factor always. Now this common factor is out. X minus 5 is out, inside is by x plus 2. Okay? That's the same thing. But quadratic, we don't need this one. Sometimes we need to scale to factor this one. This is a common factor, right? Or you can expand everything, and after that you can factor. But I'm gonna use, right, some scales. This is large x, take this as large x. Looks like this one, large x squared plus 10x plus 1. When you have a common factor over here. Use this large x, you can factor. X plus 7, x plus 3. But you're gonna replace large x plus 2. X bar little x plus 2 and 7. Now little x plus 2 plus 3. After that, we have two like terms there. Simplify x plus 9 and x plus 5. You can solve it this way too. Or you can factor, right? Expand everything. First one is x squared plus 4x plus 4. Second one is what? 10x plus 20 and plus 21. After that, you can factor this one too. 4x, 10x, 14x, 24, 29 is what? 45, isn't it? Okay, from here we got two numbers, 9 and 5. X plus 5, x plus 5. And 9 and 5, okay? It's okay? You can factor this one, same thing. It doesn't matter, this is okay, this is why we applied some skills. This is the same thing, right? Take this is what x, this is what. Definitely you better use this because inside is what? Not simple, quadratic. This one is linear, very simple form. But in this case, better use what? Large x. Replace with this one. Because inside is a quadratic. When you make a square, a lot of working. This one definitely use this method. We need the skills. Take a look. X squared minus 13, large x plus 36. Two numbers is what is that? Negative 9 and negative 4, right? That's right. Negative 4, negative 9. That's it. Now replace with little x. X goes over here. 2x squared minus 7x minus 4. 2x squared minus 7x minus 9. After that, you can check it out. This is a factorable or not. Is this factorable? Yes, it is factorable. 2x and x. One is what? Negative 4 and positive 1, right? This is negative 8x. This is a positive x. Total is negative 7x. Okay, this is fine. What about the next one? 2x squared minus 7x minus 9. Is this a factorable? Try 2x and x. How? Yeah, this one is negative 9. This is a plus 1. Negative 9x, positive 2x, total is negative 7x. This is the answer. Is it okay? Alright, this one is function operation is what we did this one, okay? That's nothing. Okay, we finished this unit 2. Now today we're gonna go into unit 3 over here, okay? That is solving polynomial equations and the behavior of polynomial functions. Okay, you know what is the polynomial? Show you a polynomial. This is the polynomial. Take a look over here. This is the polynomial functions. There's no fractions. There's no rational. Okay. A n coefficient of any variable. This is also about x to the 0, right? Yeah, kind of variable. Coefficient, all of the coefficients should be what? Real numbers. If we have imaginary, that is not polynomial, okay? All the coefficient is real. What about exponent? This exponent is also what? Whole numbers. This is x to the 0, right? This is a whole number. What is the whole number? We start from 0. 0, 1, 2, 3, 4. That's a whole number we set. What is the 1, 2, 3, 4? This is not whole number. Whole number is starting from 0. If we start in 1, 2, 3, 4, this is we set counting number. Or sometimes natural number. But whole number, variable 0. That's why we use a whole number, okay? If we have a negative, what is this one? If we have this one, y equals 3x 5 minus 6x squared and plus 5x minus 1 plus 3. This is not polynomial. Why? This is a negative number. Actually, this one looks like 5 over x. That's a rational equations. This is not polynomial function. This is we set rational equation. That is not a function. Okay? So, exponent of variable must be greater than equal 0 and greater than 0. Okay? Greater than equal 0. 1 is fine. This is a polynomial. So, domain of polynomial. Every polynomial. Domain of polynomial is what is that? All real. From negative to positive infinity. Okay? Domain of polynomial including what? Negative infinity to up to the what? Positive infinity, which is we said all real x. Every domain. Only constant, this is also what? Polynomial. Very small is the number. We said, especially we said constant functions. Linear functions, yes, polynomial. Quadratic, polynomial. Cubic function, polynomial. Combined everything, they are all polynomial functions. Okay? So, go back over here. To find the zeros of polynomial, take a look first one. This is impossible to get the what? Factored. Okay? Because this is polynomial, it doesn't have to be always what? Quadratic, okay? This is what? It can be degrees 3, degree 4, degree 5. This is one degree of polynomial. Highest number of variable, 3 is degree of polynomial. What it means? 3 means what? There are 3 roots, always. Same number of roots. But incredibly, it can be real or plus imaginary. It doesn't have to be always real, okay? Anyway, all together is 3 roots. That is degree of a polynomial. Degree of polynomial, okay, represent number of roots. It's okay? Because this is degree 3 polynomial. There will be 3 roots. Okay, to find the what? Root. First one, we can solve this one algebraically. Algebraically means what? It should be factorable. Only factorable you can use algebraically. If not factorable, you have to use a calculator. Graphing calculator, okay? Use the calculator, you make a graph over here. Where are zeros? This is real zeros. If this is degree of this polynomial is 7. For example, looks like x to the 7, something like that, right? Degree 7. There will be 7 roots. But we have how many roots there? 1, 2, 3, this is double, right? And 4 and 5. This is double, they are equal because this is bounds, that means there are 2 root. We count the 2 root. So 1 root, 2 root, 3 root, 5 root there. But this is a degree 7 polynomial. Where is the other 2? The other 2 is what? Imaginary. Imaginary root we cannot see it on the graph. Okay? Imaginary, just imaginary. But anyway, total number root is 7, okay? Alright. Anyway, we have 2 different ways to find what zeros of polynomial equations. The first one is what? Algebraic means what? It is factorable. If not, we have to use a calculator. That's very simple. Is this factorable? Yes, it is factorable. 3x and x, only one choice. Okay? So this is minus 3 minus 1. You'll get what? Negative x, negative 9x. Total is negative 10x. That's it. That's a factorable. From this factorable, we have to use what? Zero product. Okay? Zero product property. Okay, product is 0 is what? This one may be 0. We have 2 possible ways. The first factor is 0, second factor is 0. First factor is 0, x equals 1/3. Second factor is what? X equals 3. Use what? Zero product property, okay? Yep, factorable. We can solve it by our hand. Take a look. Second one is what is that? This is algebraic. Is this a factorable? Oh, this is degree 3. There must be 3 root. We don't know. Is it factorable? Try to factor. Factor means what? Factor, right? Common factor is x. X is out. Move out. Inside is what? 2x squared minus 11x plus 9. This is a quadratic. Always we need the right check. Is this factorable? Yes. 2x and x. How can you find this one? Negative 9, negative 1, right? Negative 9x, negative 2x, negative 11x. That is factorable. Equals to 0. We have 3 factors possible can be 0, right? By using zero product. The first is 0, x equals 0. Or second is 0, x equals 9 over 2. Third one is 0, x equals 1. We have 3 root. This degree 3 means what? We all 3 root are all real. The graph looks like what? They're gonna pass what? 9 over 2, 4.5, 1 over here, and 0 over here. Okay? The graph is what is there? When x go to infinite, y go to infinite, they can be this one. Move past and past this one. This is the graph of this one. So we're gonna learn why how to graph of this one, okay? Later. Okay, number 2, is this factorable? Yeah, they said algebraically they might be factorable. There's 4 terms there. We try to use what? Factor grouping, right? First 2, last 2. First 2 is what? X squared is common. X squared is out, inside x minus 5, and minus x minus 5, right? When you press this is gonna be negative numbers. Always you gotta check, right? This expression has a common factor, right? If not, they cannot be factorable. Common factor move out. X minus 5 is out. Inside the you still have 1 there, okay? X squared minus 1 equals 0. That is a factor, the form. We still continue the factor because inside the second term is what? Difference of 2 squares. Same thing. X minus 5. X minus 1, conjugate, okay? A squared minus b squared always what? A minus b and a plus b. Now we have 3 linear factors there. Now we can find the value of x, right? X is 5, second, x is 1, third one 0, x equals negative 1. That's 3 root. This is 3 root. They are all 3 root. They are all what? Real root. Okay. Okay, one more over here. X to the 4 negative 29 x squared, right? So you can use what? Little x squared is large x. It's the same thing. Large x squared minus 29x plus 100, that is equals to 0. How can you factor this one? Two numbers is what? 4 and 25, okay? Negative 4, negative 25. X minus 4, x minus 25 equals 0. But this is what linear. The answer is how much? Nope, we're gonna replace over here. Little x, large x or little x squared minus 4. This is little x minus 25. Or don't forget to replace with little x. This is original. This is still difference of squares. It can be expressed in product, conjugate pair, right? X minus 2, x plus 2. X minus 5 and x plus 5 equals 0. Well, there's a linear factor, possibly can be 0, right? Every term possibly can be 0 too. From first one, x is 2. Second one is x is minus 2. Here, x is 5. Here, x is minus 5. There's a 4 real root there. This is still real root. They are all what? Real root. There's no imaginary. Is it okay? This is we did just before, right? I'm not gonna do this one. We need a lot of things to do. X-intercept over here. This one, 1, 2, 3, 4, 5 times. It can be factorable. This is not factorable. So what are you gonna do? You're gonna use what? No choice. Use calculator. So I'm okay, I'm recording. That's right? I'm recording, right? Let me see. Yeah, I'm recording. So I'm gonna probe here, graphing calculator, okay? This is not silver TI. Okay, just a decimals. You guys can see this one, right? Let me see. I want to make sure this is over here, right? Okay. I'm gonna put this now. This is x. I'm gonna 3x4, and okay, the next one is plus 4x cubed, and minus 34x squared, right? 34x squared and minus 4x. Well, better wrong. After that, plus 16. That's it. When you see it up here, using this graph, you're gonna find the zeros. This is what x-intercept is 0, right? Another one over here. Okay. Can you see that? Oh. Okay. Anyway, I'm gonna make big. Okay. Anyway, this is the graph. We have a 4 x-intercept. That's the zeros. Okay. This one is a negative 4 first. X equals negative 4. I'm gonna make it small this. Second one is over here, negative. I forgot. 732. Third one over here, 0.667. Last one over here, 2.732. That's it. Use a calculator, okay? That's it. This is empty. Okay, use your calculator, okay? Use your calculator. But nearest tens is only what? 1 decimal place. But it doesn't matter. Yeah, you can do it number 6 using the graph. Because this is not factorable, right? Because we cannot find the common factor between 2. This is x squared out to x plus 4. The next one only about 5x plus 2. They are not common factor, right? This is not factorable, okay? Nope, factorable. So we have to use graphing calculator. This is polynomial. This is today's our main topics. today's main topic is what? End of behavior. Okay? End of behavior graph looks like what? This is polynomial. I'm going to delete this one. I need some space. Polynomial is what? The domain is negative infinity to positive infinity, right? So, end of behavior, we have 4 different ones. To the end, both one. You don't know the middle, okay, how many intersections with the x-axis, and finally, at the end of x goes what? Up. Both up. You said both end. We said end, right? At the end of a graph, end up. Both end up. Or sometimes both end down. Talking about what? End of behavior. We're gonna check right end. Behavior over end or end of behavior, right? Of the graph. Or some other times, right up, left down. Okay? So, right up, left down. Or fourth is what? This is down, this is up. It is okay? We have a 4 difference. Okay, end of behavior. How we check this one? Using these polynomials. That's the rule over here, okay? You gotta be very careful about this one. To check right their behavior end of graph, okay? Behavior, this is behavior end of graph, this is better. Behavior end of graph can be obtained what? That's only this one. Leading terms. This is the leading terms. Okay? Leading terms with what? Degree. This is the fact end of behavior. Because what? Why we need only these terms? The other terms, what happens? The other terms is what? Nothing. It doesn't affect right end of behavior. Because what? When x go to infinite, infinite fourth power, greater than infinite third power, greater than infinite second power, nothing. This is what? Much bigger than compared to the other two. That's what we don't care about, why? After first terms. Is it okay? So we care about only what? Leading terms. Degree is 4. Degree 4, take it out. When x go infinite, leading coefficient is 7, that is positive. This is the vectors we need today. When x go to infinite, degree 4 is what? Y is what is that? X go infinity, y go to what? Infinite to the fourth power. That is still infinity. Okay? Because the leading coefficient is positive. So, from here, leading coefficient is positive. So you can say over here, okay? Over here. 7 times leading infinite and fourth power is what? Still 7 times infinite power. That is infinite. Okay? If this is negative, that is negative infinity. That's the difference. Okay? So leading coefficient, right? The leading coefficient is a positive. When x go to infinite, y go to infinite. To the left, when x go to negative infinity, what is y? Negative infinity fourth power, still positive infinity. Still this is a positive, positive times positive infinity is what? Still positive infinity. The end of behavior is what is that? To the left, rise up. To the right, no, x over here, right? To the right, rise up. To the left, also rise up. Okay, this is it. This is the graph, the end of a graph. In the middle, we don't know. Middle is maybe, we don't know, right? This way, or this way, or this way. We don't know. Nothing happened. We don't care about this. Only we care about end of behavior of the graph. Okay, the behavior of end graph. Okay, we're gonna find, okay, using the graph, we're gonna make sure both sides what? Rise up. Okay, so I'm gonna show you the graph over here one more times. I'm gonna delete this one. Delete. Down. Oh, what happened? Oh, it's not delete. It should be delete. Okay, I'm gonna use this one. Okay, 7x to the fourth. Y equals 7x to the fourth. Equals minus x cubed. Minus 7x squared plus 9x and plus 11. That's the graph. Can you see over here? What? It doesn't move. I'm gonna move down over here. Oh, very interesting. It doesn't move the graph. Oh, what happened? Okay, anyway, oh, terrible. To the right, graph is what? To the right, okay? To the left, right up, to the left, right up, okay? Yeah, that is the end of behavior of graph. So we just check, okay, the graph of and the behavior of graph. Second one over here. First one, you can check, right, the leading coefficient. Compare this to nothings. Degree is 3. Leading coefficient 2 is a positive. So now check out when x go to infinite. As x go to infinite, to the right hand side, what is the value of y? 2 is a positive. This is the infinite cube, still positive infinite, because still y is increased positive, going up, rise up, right? When x go to infinite over here, this is also going up over here. To the left, x go to negative infinity, okay? Negative infinity. Okay, negative infinity cube is what is there? Still negative, right? Negative times negative infinity, you can say cube. Negative 3 times still negative. Is okay? Still negative. This is a positive. This times is what? Still negative infinity. To the left hand side, when you go this way, to the infinity to the left, the value of y is what? Fall down. Okay? Yeah, that's the y behavior end of graph. Okay? Alright. A little more over here. Okay, you guys have some practice right now. Let's get 1 minute. This is what time is. Okay, we stay time. Okay, we try this one together anyway. Leading coefficient, leading term is 2x minus 3, degree is 3, and the coefficient is positive 2, right? is positive. This is a leading coefficient. LC, I'm going to, and LC equals 2. Because this is important, right? If this is a negative, they change the sign. Now, x go to infinite, y go to y. Infinite cube is still infinite, positive infinity, but leading coefficient is still positive, go infinity. Positive times positive is still positive. Now when x goes to the left, negative infinity cube. Negative infinity cube is still negative infinity, right? Negative times negative, but still leading coefficient positive, positive times negative, still negative. That's the opposite way. So what is the end of behavior? To the right, rise up. To the left, rise down. I pull down, right? Yeah, that is down. Okay, this is down to the left. This is up to the right. Is it okay? So I'm not going to do number 5. This is same thing, right? Degree 5. This is even is one side is up, the other one is down. Okay, if this is up, the other one is down. Okay, opposite way. Even number is what is the even degree? 2, 4, 6 is what? They are both increase or both down. One of this one. When you have right exponent, degree is even. Degree is up, is one side up, the other one is down. Okay, opposite way. This is opposite way. Because degree is 5 and LC is 1 positive. When it goes to infinite, what is the goal? Infinite 5 is still infinite. Now you go to the left. Negative 5 is the fifth power, still negative. So rise up, left down, opposite way. 4 is what is the positive, both up. Because what leading coefficient is still positive leading coefficient. LC is 1 over here, okay? What about here? This is different. LC is 1 negative, negative 1. The degree is 4. When x goes to infinite, what about y? Infinite 4 still positive infinite, but with multiply leading coefficient negative sign is gonna be negative infinity, right? Change the directions. When x goes to negative infinity from fourth power still positive infinity, it's okay? But we still have right leading coefficient negative number. From here times negative still y equals negative infinity. This is 4 is even is the same direction, but depends on this number. Both what down. If this is positive, both up. That's the formula, okay? This is negative, that is even number, both will be down. We already know that. Okay. X is negative 3, try this one. Degree is 3, leading coefficient is negative 1. Be careful, this is a negative number. When x go to infinite, y go to what? Cube is what is that? Positive infinity, but still have a negative. So it's going to be negative infinity. When x go to what? To the left hand side, negative infinity. What about y? Negative infinity cube is still negative infinity, but we still have a negative LC, leading coefficient is still negative number. We're going to multiply these two, negative 1 times negative infinity, positive infinity. This degree is out, it's going to opposite way, but when you have a negative, this is down, this is up. If this is positive, this is up, this is down, okay? Oh, too much. This one you guys have some practice over here, okay? But with this one, we don't need this one. That's over here. Summarize. The end behavior of polynomial. Polynomial is what? Negative infinity to positive infinity. That's the domain. Okay? Okay, when x go to infinite, even degree, both what? Same directions. Okay? even degree, but it depends on what? Leading coefficient, right? Leading coefficient is positive. Even degree, something like this one, 5x to the 4. The next one is forget about this one. When x equal to negative infinity, positive infinity, still positive, still, this is what? Positive infinity. To the right, positive infinity, both what? Positive infinity. This is the both up. Okay, both you can say both ends up, that's it. Because the leading coefficient over here, LC is what? Positive. This one is degree 2 also positive. Okay, negative infinity times degree 2 still positive, right? Negative times negative always make it positive. Odd degree is the opposite way, okay? Left down, right up, or left up, right down. It depends on what, which one is down, which one is up. It depends on LC. When it's equal to negative, if LC is positive, for examples, y equals LC is positive. Negative cube number, still negative infinity, but LC is positive, still negative infinity. This is what? Positive infinity, right? Positive cube is positive. This LC is positive, still positive infinity. Left down, right up. That's a summarize. Over here, both will be even, still same directions, but it depends on LC. At this time, LC is a negative number. Negative 4, any even number make a positive, but we have a LC is what? Leading coefficient is negative. Negative times positive is still negative. This is also negative. So both what? Down. It's okay? So you can say both ends down. Simply, okay? You can say it this way. The next one is still degree 3 is what? Both sides the opposite way. One is up, the other one is down. But this time, leading coefficient is negative. LC is negative. Cube. Degree is cube. So minus x cube, how much? Still minus infinity, right? Minus infinity. Cube is still minus infinity. But we multiply LC to these numbers. Negative times negative infinity. Positive infinity now. Positive infinity is what? Rise up. When it's go to infinity, infinite cube, positive infinity, but we multiply minus to this positive infinity, it's going to be negative infinity, okay? So this final is what? Negative infinity. Left down. It's okay? So you can say left up, right down. No. No. They have a negative sign, negative, negative, positive, right? No, this is wrong. No, this is wrong, okay? Left down, right is up, okay? Because when x goes to infinite, no, it's okay. Oh, this is minus. This is the right. This is correct. This is minus, okay? Not to the right. This is positive to the left. That is left. And the right is what? Down, okay? Yeah, this is correct. Left up, right down, okay? Just simple, you can say it this way. Now the next one is even function and odd functions. Okay, we're gonna have one more practice about over here, okay? From the graph, both sides what? And up, isn't it? What is the degree of this one? Approximately. You can say degree is what? Even or odd. Same direction, it should be even. Both sides up, what is that? Side of leading coefficient is what? What is that? Positive. It's okay? That's why both are up. This is one side up, one side down. That is what? Degree is odd numbers. But right hand side, right end is pulled down. Down is what? Negative infinity. Cube, but we take what? Negative sign. That is LC is a negative sign. In this case, the right down, left up. And okay? But I think it is okay. So remember, summarize one more times. Okay? And it's even, A is positive, ends up, both sides ends up, and A is negative, both ends down. N is positive, N is odd, A is positive, right up, right down. When A is negative, okay? A equals what? Leading coefficient, LC, okay? Okay, end of behavior. I'm going to choose some questions over here. This one and this one. Leading coefficient, negative x to the 4. Negative 1 is leading coefficient. I'm going to write down LC is 4. Okay. Degree is 4. LC is negative, what I'm doing. Okay, negative 1 times x to the 4. When x equals what? Infinite, y close to y infinite. But we take what? Negative side, negative infinity, right? The right down. When x go to negative infinity, fourth power still positive infinity, but leading coefficient negative, it's gonna be negative infinity. Both what? Ends down. Okay, so I'm try this one. This is positive. Degree is what? Even. Both what? This is positive. Both what? End up. Okay, both end up. Okay. You want to make sure over here. End of behavior functions. There are many over here. You can check it out. Okay. So next time we're gonna go over some of these numbers. Okay. Okay, we'll try exercise 1. This is the quadratic, okay? Second degree polynomial equations. The first end state, end of behavior functions. LC is a positive. 1 is positive. And degree, D equals how much? 2. Degree 2 means what? Both sides end up or end down. But LC is positive. Both sides end up. That's right? Or you can check it out. When x go to infinite, y go to infinite square. This is still positive infinity times LC positive finally infinite. X go to negative infinity. Y is what is that? Negative infinity square positive infinity, but we multiply another LC is positive, that is positive infinity. Both end up. When you make a graph of this, what is this one? X plus 3 squared, isn't it? X equals what? X-intercept at x equals negative 3. Both sides end up. It's okay? Okay, after B, we're gonna finish today, okay? Oh, over here. Find the zeros. Find the zeros is what? When set value of y equals 0, okay? X squared plus 6x plus 9 equals 0. You can factor this one. X plus 3 squared is 0. And x equals to negative 3. But this one is only one value, but actually they are bounced. Actually there are two zeros, but they are equal, right? Yeah, this point is bounced. Okay, this is a multiple list. We said multiple list of zeros is 2, always bounced. So we're gonna, okay, learn what is the multiple list of zeros. Okay, if multiple list of zeros is an even number, always bounce. Other number always pass. Find Y-intercept. How can you find Y-intercept? Set x equals 0, right? Over here, x equals 0, y equals 9. This is 9 over here. That is Y-intercept. Y-intercept, y equals 9 or y 0 and 9. Okay. Sketch the graph of the function without using calculator. We did already. Over here state, because LC is positive, okay, because our leading coefficient is 1, that is positive, and check it out. This is other, okay, when x goes to infinite, x cube, infinite cube still infinite, y approach infinite, because that is positive. X goes to negative infinity, this is goes to what? Negative infinity cube, negative still. Rise up, left down. Rise up, left down. Using this one, we can make a graph. Find the zeros. Okay, this is very important. How can you make? How to graph a polynomial function. This is our main topic today. Why we need Y-end behavior to make a graph. That's it. What is the zeros? Anyway, to make a graph is a little, right, nicely and correctly, we need what? Zeros or Y-intercept. Because we don't know what happened between these two. Rise up, end up, we don't know. Okay? At end of behavior, only we got it. But before these two end of behavior, we don't know nothing. Nothing information is there. So to find some more detail, we need to find what? Zeros. Zeros is what? Y equals 0, okay? So x cubed, this two is a grouping. X squared is out. That's why we learned the grouping factory, okay? X plus 1 and minus 4 x plus 1 to make a 0. Okay? So x plus 1 is a common factor out. X squared minus 4 is inside the parentheses. Keep going. Another factor, right? This is a difference of two squares. X plus 1 times x minus 2, x plus 2. Conjugate pairs equals 1. We have three zeros. X equals negative 1, x equals 2, x equals minus 2. Check it out, the negative 2 over here. The graph will pass this one. The graph will pass 2. The graph will pass this 2. But there are multiplies is 1, right? 1 is what? Always pass the point. Graph will pass the point. This is degree 3. All degree 3 is what? All root is what? They are all real. Oh, the graph end of behavior over here. The graph over here going down. Okay, not this way, okay? Graph going down over here. So, it's over here, right down. Pass, pass, pass going down. This is going down. This is going on. Okay, using this point, we can make a graph. Okay, this is the approximate graph of this one. And also, if you give a Y-intercept, much nice looking graph. Where is the Y-intercept? Additional point. Additional, more accurate graph with the additional point to specify Y-intercept. Y-intercept is how much? Negative 4, right? When x equals 0. When put this number x equals 0 there, Y-intercept negative 4, right? This one you can say negative 4. Oh, this is around the 1 over here. That's not negative 4, right? A little nice looking. 1, negative 1, negative 2, negative 3, negative 4. It's going to pass this one. Much nice looking. So a little change this one. Adjust. This one. This is much better, right? Yeah, this is the way to graph polynomial functions. Okay, so we're gonna learn the next more detailed multiple list of root. What is this one? Multiple list is what even number is gonna be bounced. It's gonna be odd number passed. Okay, so using this tool, maybe next times we're gonna graph a little in detail, nice looking graph. Okay, all right. So anyway, there is no homework today. Just figure out one more times. Okay, so how we make a graph? What is the end of behavior? Why we need end of behavior graph? We need a graph of this one. We need a graph where we start to start past this one over here, right? Not here. At the end of up here, y is infinite. We start from here. Okay? Alright. Okay, we'll continue multiple list the next time. Okay? This is very important, your algebra tool. Okay? If you have any questions, you can email to me, okay, anytime. I can explain, okay, on YouTube. Okay? Okay, I think we finished today. Okay, thank you so much for joining class. I'll see you next time. Okay, bye everybody.